All right, let's talk about something that's absolutely critical for any serious Python developer: object-oriented programming. If you think of yourself as a software architect, well, this is your guide to building code that's strong, clean, and professional. Okay, let's get into it.
So first off, why should you even care about this? I mean, really care. Well, if you're aiming to land a Python job, listen up, because this isn't just some nice-to-have skill. It's an absolute must-have.
The reality is, if you look under the hood of almost any professional Python project, we're talking web apps, APIs, big backend systems, you're going to find OOP at its heart. Mastering this stuff isn't just for a test. It's the key to actually building real software and, you guessed it, landing that job.
So let's start by laying down the foundation. The entire massive concept of OOP really just boils down to one simple but really powerful idea: the difference between a blueprint and the actual thing you build from it. A class, that's your blueprint. It doesn't actually do anything on its own. It's just the design, right? It's the template, the set of instructions for what you're planning to create. It defines all the properties and the behaviors that anything made from it is supposed to have.
An object, on the other hand, well, that's the real deal. It's the car that actually rolls off the assembly line, the house that gets built from the plans. It's a real, living instance of a class that you can actually use and mess with in your code. So how does that blueprint, the class, actually turn into a real object? Well, that's where the constructor comes in. In Python, this is a special method called _init. The moment you create a new object, this thing runs automatically. It's like the factory foreman that takes the initial details, like Toyota and 2022, and uses them to build and set up that brand new object just for you.
Okay, so our foundation is solid. Now, let's build on top of it with the 4 pillars of object-oriented programming. You're going to want to pay close attention here, because I can almost guarantee you these concepts are going to come up in any technical interview you have. These are the fundamental rules of good software design. First up, we've got encapsulation. The main idea here is pretty simple. You bundle the data and the methods that operate on that data all together in one neat package, and then you protect it from the outside world. It's just like a capsule. All the important stuff is sealed safely inside. And this example shows you exactly why that's so important. Think of your bank account balance. You don't want any random part of the code to be able to just reach in and change that number, right? No way. So you lock it away. To interact with it, you have to go through official methods like deposit or get_balance. This keeps your data safe and your code predictable. Next up, pillar number 2, inheritance. This is all about not repeating yourself. It lets you create a new child class that automatically gets all the features and methods from an existing parent class. You write the code once in the parent, and all the children get to use it. Just look at this. The animal class has a speak method. Because our dog class inherits from animal, it just gets that method. We never had to write a speak method inside the dog class itself, but our dog object can still use it. It gets that power for free, which is just incredibly efficient. Pillar number 3 is polymorphism. It's a fancy word that just means many forms. The idea is that you can have one single name or one interface that can mean different things depending on the context. In our code, it means we can call the exact same method on different objects, and each one will respond in its own special way.
And this is the classic example. You have a cat and a dog, and they both have a speak method. When we just tell an animal to speak, Python is smart enough to figure it out. If the animal is a cat, it meows. If it's a dog, it woofs. It's the same method call, but we get completely different behavior. That's polymorphism.
And our final pillar is abstraction. This one is all about hiding all the messy, complex details on the inside and only showing the simple, essential features on the outside. It's like creating a contract that other classes have to follow. So here, our shape class is abstract. You can't actually make a shape object. It's more of a rule book. It says, hey, any class that wants to call itself a shape must provide its own area method. This forces the square class to follow the rule, which keeps all our shapes consistent and reliable. Okay, so you've got the 4 pillars down. Now, it's time to level up. Let's get into the professionals toolkit. These are the concepts that really separate the beginners from the seasoned software architects. So this is a really crucial difference to understand. A class variable, like species, belongs to the blueprint itself. That means it's shared by every single object you create from that class. But an instance variable, like self.name, is totally unique to each specific object. So every dog is a canine, but each dog has its own name. Now, this is a huge one in modern software design: composition. Instead of an is-a relationship, like we saw with inheritance, a dog is an animal, composition gives us a has-a relationship. You build your big, complex objects by basically putting other smaller objects inside of them.
The perfect example is a car. A car has an engine. It wouldn't really make sense for a car to be an engine, right? So instead, when we build our car object, we also create an engine object, and we just put it inside. This has-a approach is super flexible, and you see it everywhere in big professional systems.
And finally, let's talk about the @property pattern. This is how pros manage access to an object's data. It's a three-step dance. First, you make an attribute private. Second, you create a getter that lets other code read it. And third, you create a setter that acts like a security guard. It lets you add logic to check any new value before it's actually assigned, which is amazing for preventing bugs.
Wow, okay, we have covered a lot of ground. We've gone from the basic blueprint all the way to professional design patterns. So now it's time for the final inspection. What do you absolutely have to know to nail that job interview?
This is it. This is your checklist. If you can confidently explain every single item on this list, the 4 pillars, why you'd use composition, how a property decorator works, the difference between a class method and a static method, you are going to be in an amazing position. You'll prove that you really understand professional Python. Look, theory is great, but practice is where the magic happens. The single best thing you can do to make all of this stuff stick is to just build something. It doesn't have to be huge. A simple banking system, a little shopping cart, that's the perfect way to make these concepts really click into place. So we've walked through the architect's guide. You have the blueprints now. You have the patterns for building robust, professional, amazing Python applications. The only question left is, what are you going to build?